Welcome. In this video, we will take a look at another definite integral example. So we have the integral from -4 to -1 x squared times 3 minus 4x dx. So on first account, it looks like this is a little more complex than we've seen before, but with a little bit of rearranging, we can actually work this with our regular power rules. So we'll notice that we have an x squared here multiplied by a binomial term. Here we can actually use some multiplication and distribute that x squared throughout that parenthesis and come out with two power terms. So let's do that. We'll just start by rewriting our integral. -4 to -1, we'll have 3x squared minus 4x to the third dx. Now we can consider taking the antiderivative of each term in our integral. So we'll start with the first 3x squared. We're going to add 1 to the existing power, which would make it a 3, divided by the new power of 3. Minus, we'll have 4, x to the third becomes x to the fourth over 4. We'll notice that each of these will kind of nicely cancel out. We'll have the 3's cancel, the 4's will cancel, and I'm left with x to the third minus x to the fourth. And I'd like to evaluate this antiderivative. This is my capital F of x. I'd like to evaluate this at the points -1 and -4. So with the fundamental theorem of calculus at work here, what I'm really finding is big F of -1 minus big F of -4. And we'll do that right underneath. This again will give me the area underneath this function's curve from -4 to -1. So let's go to work evaluating this. First at -1, we'll have -1 cubed minus -1 to the fourth. All this will be subtracted by -4 raised to the third minus -4 raised to the fourth. So there's a lot of negatives in this problem, so let's walk it through slow, making sure we have the right sign on each of our terms. -1 cubed, starting on the left side here, is going to be -1. Minus a -1 to the fourth, that would be a total of 5 negatives, and still just going to be 1, so that'll still be -1 when we're done. Subtract everything by -4 raised to the third power. Well, -4 times -4 times -4 will give us 64, and there's 3 negatives involved there, so it would still be a negative. And that would be 64 as the value. And then we'll have a minus -4 to the fourth power. That's 4 negatives there, which become a positive term. And so 4 raised to the 4 is going to be 256. We still have some negatives to work with. We have -1, -1 is -2. And then this negative sign we'll want to just distribute. We'll notice each of these following terms will become positive. So plus 64 plus 256. And if we add this all together, left to right, we will end up with 318. So there is 318 units of area accumulated underneath this original curve from -4 to -1. So I hope this is a helpful definite integral problem that will help you in learning this subject. So I hope to see you in the next video.